In previous screencasts, we talked about that the fact that we are looking for evidence of a link between human activity and the increase in CO2 and other greenhouse gases and temperature or climate change, global warming, excuse me. So first we need to look at the relationship between carbon dioxide and temperature. So on this graph, you can see time in years before present, with present being on the right-hand side of the graph and going back in time as you go toward the left. And along this axis, you have CO2 in parts per million. And on this side, you have temperature changes in degrees C compared to present-day temperatures. So the purple line is the CO2 value, and the blue line is the temperature change. So you can see there's a very, very tight correlation. When the CO2 is higher, the temperature is higher. When CO2 is lower, temperature is lower. So they are very, very closely intertwined. What this graph doesn't answer is whether it's a case of the chicken or the egg came first. Was the CO2 higher and therefore the temperature was higher? Or was the temperature higher and therefore the CO2 was higher? So there are a couple of ways that we can look at that data to answer that question. They are interrelated, but in a laboratory, you can increase the concentration of carbon dioxide in an enclosed system and shine a light on it, and you will see that the temperature will increase, and that there's a direct correlation between the concentration of carbon dioxide in that contained sealed container and the temperature. So CO2 definitely can come first and cause an increase in temperature. On the other hand, if you look at the oceans, when the oceans are warmer, they release more CO2 into the air. So therefore, we have, in that case, the increase in CO2 coming before the increase in temperature. But the bottom line to remember is they're both closely related. When one goes up, the other goes up. In an enclosed system, the CO2 increase precedes the temperature increase. But because we have complex global systems, that isn't always the direction that things will take. So here's another graph looking at increasing CO2 concentrations, this one just from 1958 to 2010. There was a doctor named Charles David Keeling who began measuring carbon dioxide concentrations back in 1958. And here on the x-axis are your years, and here on the y-axis is your CO2 in parts per million. And you can see there's a very definite increase in CO2 as you move through the decades. So in 1958, it was below 320. By 2010, it was just below 390. And today, if we were to continue the graph, we'd be up here at 413. So there's a clear trend in increasing CO2 concentrations, which also corresponds with increasing temperatures. Why did CO2 increase during those years? Was it natural or man-made? Well, beginning back in the 1850s, we've talked about how we had the Industrial Revolution, and as part of that, certain fossil fuels, originally coal and then other fossil fuels, were increasingly burned. By the 1950s, there was a fairly significant rate of fossil fuel use occurring, and that has continued to increase in the recent decades. Now we'll take a look at historical CO2 concentrations. So again, these are measurements primarily taken from the ice cores. And you can again see the cyclical nature where there are peaks and valleys, warmer temperatures and ice ages. And here we are right before present day, where it would be 280 parts per million or less. You can see that there's been a significant overshoot that brings these values higher than any values that we've seen in the past 400,000 years. There is some evidence, if you go back 650,000 years, there's some recent evidence of a warm trend back then. However, and I don't know the cause, scientists don't know the cause of that, but even just looking at the last 400,000 years, you can see that we are definitely on a different trajectory. And in fact, if we look at how the cyclical pattern has existed, what we would expect to happen in the current age is that we would be going into an ice age. The temperature should be dropping, and the CO2 levels should be dropping, not increasing. So putting it all together. So we know an increase in CO2 level in the atmosphere causes a greater capacity for warming through the greenhouse effect. We know that when Earth experiences higher temperatures, the ocean warms and it cannot contain as much CO2 gas. As a result, the oceans release the CO2, which increases the amount in the atmosphere. So altogether, it's a cyclical effect. A warmer Earth causes the oceans to then release even more CO2, and the more CO2 causes the Earth to become even warmer. And so we get the following effect. On the left is shown a positive feedback loop, and on the right is a negative feedback loop. So remember that with feedback loops, a positive doesn't mean that it's a good thing. It means that it's a continually increasing, spiraling up. So here we have a certain amount of CO2 in the atmosphere that promotes higher temperatures in the atmosphere. As the temperature increases, then there's faster rates of decomposition. And as decomposition occurs, there are increasing amounts of CO2 placed into the atmosphere, as well as methane. So it cycles up and up and up. On the right, we have an example of a negative feedback system. There's increased atmospheric CO2, carbon dioxide, but CO2 can be taken up by plants as a nutrient through photosynthesis, and therefore these extra CO2 that went into the atmosphere, at least some of that can be taken up by plants, and therefore that keeps the cycle in balance. Now, in reality, the plants have not been able to keep up with the atmospheric CO2 that has been produced by humans. So the plants have been able to increase plant growth and absorb about 50% of the increased atmospheric CO2. So that is something, but it's not everything. Now, one of the complexities of looking at climate change and warming is that we rely on mathematical models, computer models, to predict from what is happening now, the global processes that we can observe, and predict what will happen in the future. And as a result, there are different estimations or predictions made by various groups of scientists. So some show a low increase in CO2, and then the world would get a bit warmer by, let's say, 2 degrees. A moderate increase in CO2 concentrations, where perhaps we have a surface temperature more like 4 degrees increased, and a very high increase in CO2, which would lead to a near catastrophic, if not catastrophic, temperature change. So one thing that you will notice is that no matter what the level of predicted increase in CO2 you use, you still do have consequences. And in some regions, these are very serious consequences. So now let's take a look at emissions that are producing the CO2 and methane and so forth from developed countries and the developing world. So the graph on the left is millions of metric tons of CO2 produced by a country as a whole. And you can see that China surpasses us slightly in the production as a whole of CO2. The United States is second, and India comes in here at fourth, with Russia in third. So all of these numbers, the China and the US numbers, are quite a bit higher, many, many times higher than these countries. In fact, they're more like all of these countries put together. On the right here, we have a graph that shows CO2 emissions per capita, so that's per person. So in Australia, which was way down here on the amount produced by the whole country, the amount produced per person is very high, with the United States coming in second, Canada, Saudi Arabia, and other developed countries being quite high in the per capita emission of CO2. And China moves down here per capita, and India moves down here per capita. So some of the points are that both developing and developed countries do produce CO2, and we all need to be together in figuring out the solution to this problem, and that one person's air is another country's air. So again, it all needs to be worked out together. Okay, the last or second to last screencast will be on the consequences of global warming.